Yes, I know. Don't worry about that. Okay, let's start. Yay. At least I got my stuff done. Have on full screen. Duplicate slideshow. Yep, all good. All right, listen up. Shh. You have seen this. I don't have to say any more. Samyak and Murad, please pay attention. Your voice has just been recorded. Thank you. This is the section that we're going to go through. You don't have to see this. This is just an opening title. All right, but this is the last time that we're going to see this. Promise you. Last ever for this section because we're going to move on to space sciences next week already. Okay, space sciences. Cool. Now, when you see this particular section here, as you know, the arrows, copy your notes after the lesson because this is a type of note taking I'll try to give to people. You have to listen first because once you listen, it's much better to write it down than to write it down at the same time when you copy. It's not very effective. All right. Homework, you definitely have homework as well because this entire section is homework and there will be a next section for you to do your research on. All right. These are your learning outcomes 3, 4, and 5. All right. Number 2 is done in the practicals. If you go through your assessment plan and stuff, I don't have to go through this because this is what we're going to go through after this. All right. Let's just try to revise on the rock cycle. You know, igneous, sedimentary, metamorphic, and you have all the beautiful arrows coming here and jutting out here and there. Okay, so this is just basically a cycle. You need to have a cycle for these rocks is because you need to recycle. All right, the reason why it's a cycle is because everything has to be utilized. Everything goes back into the earth. That's what it means. Guitar, please pay attention in front. Jacob, in front, please. All right, all heads face in front. Nobody faces the computer or laptop, please. Thank you very much. Next one. Have you guys seen these? Right? This is when we went to the museum. All right. What happens here is there is a section that I need to mention to you. Some sedimentary rocks, when upon compaction, you can actually form your metamorphic rocks. So from this one here, limestone. Let's see how limestone here is. Very brittle, rocky, not very colorful indeed. But as soon as it undergoes intense heat and pressure, those are the two factors involved in the formation of metamorphic rocks. You have marble instead. And definitely we will utilize marble floors, for example, marble, if it's marble walls, that'll be fantastic. But marble is actually very cooling in this case here. All right. Rihanna, just put it back. Okay. Sandstone to quartzite here. Okay. This is another example. So sedimentary, limestone and sandstone are sedimentary. Metamorphic will be marble and quartzite. It's actually from the same rock. But because of heat and pressure, it has changed. It has metamorphosized. It has evolved. I'll put it that way. All right? This is what's happening here. Rocks, minerals, and also ore. All right? Rocks are actually made up of chemical substances called minerals. So whatever rocks that you see at the back over there, they are actually made of substances called minerals. Within the rocks itself, you have those beautiful sparkling and shining things. Those are your minerals. Your minerals here are naturally occurring liquid or solid on the Earth's crust, in the Earth's crust. You can only find them in the Earth's crust because remember, why is it found on the Earth's crust and not in the mantle? Does anyone know? Why do you find minerals more in the Earth's crust rather than the mantle? You have no idea. What's yes? That is absolutely correct. Yes, Rihanna? That's correct. Mantle is hotter, and because there's more pressure, you have less minerals being formed. So that is why you only find it on the crust. The crust will have a hotter temperature as well, but not as hot as the mantle. So good. You have made the connection between the structure of the Earth and the formation of minerals. Bravo. The ores, all right? Rocks which contain minerals are known as ores. O-R-E-S. Okay? Next one. Now, remember when you have seen properties of these minerals when we went to the museum? You have hardness, and this is the most hardness scale. So we try to compare and give a numerical value to each of these minerals to say that, yes, this is much harder than this. Gypsum is harder than talc, calcite harder than gypsum, and diamond being the hardest. All right, and that's why we always say diamond is the hardest material in the world. Okay, and of course we will say diamonds are a girl's best friend. Right? So girls, make sure that you stock up all your money, stock up everything, and when the time is right, ditch the boys all right, and go for your diamonds instead. This is an alternative test for hardness here. Okay, fingernails, copper washers, and I'm not really fussed up on this, but it is just only to tell you that if you're using a test object, for example, a fingernail, and if you're able to scratch it, the hardness is less than 2.5. That's what it means, all right? If it's a steel knife or a nail, it'll be less than 6 in terms of the hardness of the mineral, okay? Another few more properties: luster, color, and streak color. What does that mean? Let's compare these two here. These two are of the same ore or the same minerals. This is a red hematite, which is iron oxide, and this is a black hematite. All right. Luster is how shiny is the material. Is it shiny or is it not shiny? Sorry, Rihanna, just place the test tubes and just concentrate in front, please. All right. Don't disturb it because if it breaks, it's not going to be good. Okay. Color. You can use color to distinguish the minerals, but again, you have to make sure that you describe the color properly because there are some minerals where the colors overlap. Streak color. This is the color left behind when you scratch it with a white towel. So eventually, I can tell you this, the hematite here, although they are different in terms of its color, but both of them will give a red streak color because iron oxide is actually red in nature. All right, and these are your common minerals. All right, hematite is the particular mineral we're talking about. Within the hematite, you have iron oxide and has the main component of iron. So whenever you see these boxes over here, iron oxide is actually the chemical compound, whereas iron here is the main element you see within the ore itself. All right, you have bauxite, you have galena. You'll be able to go through this bit by bit, and this is all taught in chemistry, but we will touch a bit of chemistry and bio in between, but not so much of these. Okay? Has anyone seen this? Where have we seen this before? The museum, all right? Azurite and malachite. And the funny thing here is with this azurite, there are some malachite minerals on the azurite, but it's predominantly with azurite. So guys, the conclusion we can make here is it doesn't mean you have one mineral existing on its own. Shh. You don't have one mineral existing on its own. It's a coexistence. All right. And at the bottom here, copper carbonate, which is, mainly copper. Copper hydroxy carbonate, which is mainly copper, and the hydroxy component inside here, OH. All right. You have rutile. You have opal. Guys, have you seen opal somewhere in Adelaide here? Yes. Where can you find these shops? Yes. Sorry? Cooper Pedy. But where can you purchase them? Yes. Good girl, all right? If you see an opal factory over there on King William Street, this is where they have the opals, the gemstones, okay? And you have also cassiterite. See, these common minerals, I don't expect you guys to memorize, all right? I really don't want you to memorize. There's no point memorizing. Distinguishing is better. Samyat, please pay attention. All right? And these are the next few minerals that you will see later on, but you can just read it because it's been recorded, so it's not a problem for you. Sorry? Oh, really? Oh, that's good. That's copper sulfide, and copper is the main element inside. When you go into chemistry, you will learn all the names: nickel, sulfur, copper, iron, chromium, and etc. Okay? Now, how are minerals formed? Minerals are formed based on the rocks because remember, minerals are contained within the rocks. So if some minerals are formed from the crystallization of the magma, what sort of rock is this? Igneous, good. If some minerals are formed by metamorphic processes, what sort of mineral is this? Huh? Huh? Metamorphic. Hello. I've given you a clue here. Metamorphic processes. Ah, now only you realize it. Semiac? Last one. Minerals are formed in sedimentary. If you don't know this, I have no idea. So what's a rock? Thank you very much. If there are no clues here, you know you're going to get it from me. All right? Because the clues are obvious here. This one here might be a bit tricky. Okay? Now, This is actually a region in Western Australia called the Pilbara region, and this is where you can find iron ore. Guys, what sort of rocks do you see which have been deposited over here? Sedimentary. So within the layers of this sedimentary, where the sediments are deposited, that's where you have your ions being formed, all right? The deposits, which is some of you have mentioned, or the sediments, are in between the layers of the rocks over here. So that is when iron is formed. But in order for you to take out the iron from the earth itself, you need to extract, all right? It's a process. Extraction is a process where you take out the minerals from the particular rocks itself, right? Whether it's for selling purposes or for business or for retail, whatsoever it may be, right? So that's why Western Australia is very popular, because it is the only, not I won't say it's the only state, it's one of the states in Australia here which has lots of minerals. It's the mineral state, all right? That is what I'm trying to tell you in this case here. We do have in South Australia, but not as much as in Western Australia, okay? The next one. The funny thing about this iron ore, rather than it being deposited, it is actually being dissolved. The iron compounds are being dissolved. It precipitates in between the layers, right, and is carried down from the surface. Guys, how is it carried down here? What sort of agent is helping it? Yes, Rihanna. Water. Water is helping now. So you see, all the physical and chemical factors that you have learned so far, precipitation, dissolving, and also transport by the means of water, is all coming together. This is a good application. All right? So the iron compounds will solidify around the small grains, and eventually it will build up in those large gravel-like rocks, and you'll be able to extract them. Jacob, could you please pay attention? All right. So now, this is your work. Later on, I'll put this on day map. Don't worry. This is what you need to find. We have copper ore and also gold as well. I need to use, I need you to use the internet or your textbooks that you have so far to actually do these questions, all right? How are the minerals formed? Draw a diagram to describe the formation of the minerals. How are the minerals extracted from the rocks? And what can the minerals be used for? Now, in terms of the diagram, because copper ore and gold, in terms of its extraction or how it's formed, is almost similar. So you can use one diagram to describe how copper ore and gold are actually formed. And you need to do this as your homework, all right? Your homework is not only just to copy what I've explained in class, but it's also this one. Is it a lot for you to do? Very much, okay? So you have to really do this. And on top of that, those who are absent that day, we have worksheets 3 and worksheets 4. Could I ask you to see me today at the very start of recess so I can hand it over to you? All right, those who are absent today, please see me at the, the alley over there. It's just walking all the way down. You'll see me there. All right, please make sure. Okay? Next lesson, space sciences. We're going to be Buzz Lightyear. We are going to be Buzz Lightyear from Toy Story to venture into space. Okay? Sorry, which one was that? Oh, you mean this one here? You mean this one? No, don't worry. I will put it on day map. Check it on day map. But write it as a homework, okay? Sorry? Yep. What? Sorry? Foodie? Or Woody? Oh,